So you can try out the third one. So that's two identical spherical charged metallic spheres are hung by strings, and the strings make 60-degree with each other in vacuum. When the whole arrangement is kept in a liquid of density 0.5 gram per cc, the angle remains the same. Calculate the dielectric constant of the fluid density of the square is equal to 1.5. Oh, there's some. Let me check. I think there is some language mistake in the last sentence. So like basically you have to calculate the dielectric constant of the fluid density, right? So you just try out. So what they're trying to say is that two strings are there. They are at an angle of 60-degree. Spheres, the angle between them is 60-degree. So that is in vacuum. Then the same arrangement is dipped on a liquid which has a density of 0.5 gram per cc. The angle remains unchanged. So you have to calculate the liquid dielectric constant. Dielectric constant is the same, that is the permittivity of the medium, which is the fluid. So how will you do that? So remember last class we had done with some equation, right? Theta. How will you find, use that. Like tan theta is equal to Fe upon mg, right? So what are the forces which are acting when they are in vacuum and when they are in a medium? So you have to consider both the cases. And the angle is remaining the same. So what you can do is that first you find in vacuum. Vacuum, what will be this? Remember mg, the forces acting here, tension T, yeah, and a repulsive force, that is Fe here. So what we had done, we had found the equations using the free body diagram, right? So what was that? This angle is 60-degree. So this becomes 30-degree. This is the tension T, mg, Fe. So we resolve this T into two components. One was that this angle is theta, so this will be also theta. So T cos theta and T sin theta. So you have taken theta is equal to 30-degree. So T sin theta is equal to Fe, the electrostatic force in vacuum, and T cos theta is equal to mg force. So when you divide this, we have got tan theta is equal to Fe upon mg, right? So Vfe upon, now mass of this body is given, right? And what had they given? They had given the density, right? So if you write in terms of density, it will be density into volume and this G. So we have got the first equation. Now the same thing they have immersed in a fluid, right? So the same thing they have immersed in a fluid. So then in that case, you find the forces acting on it. One will be mg. Tension will be changed, T dash, right? So two components, T dash sine theta, T dash cos theta. The repulsive force, then repulsive force will also change, the force in the medium, right? And any other force?
Point.
Yeah, the upthrust, right? So the upthrust will be also acting, and that will act on the T cos theta direction. So we can say T dash sine theta is equal to Fm. This is the first equation, force of the electrostatic force in the medium. And then T dash cos theta plus the upthrust is equal to mg, right? So when you find the tan theta, what you will get? Okay.
Fm by mg minus 1.
Fm upon mg minus the upthrust force. So that is our equation 2. Now, what have they given? They have given, you have found tan theta, yes. They have given rho also, right? So where do you use that to find the upthrust value? What is the upthrust value? V rho G. You put that value and then you solve the equation. So have you solved? Have you got the epsilon r?
13.2 into 10 to the power minus 12.
Answer is 1.5.
We have to find the ratio or the
Dielectric constant.
okay. Yeah, so that is 1.5.
1.5. Okay. So tan theta is equal to how much? Expression of tan theta now. When you put the value of so we have got tan theta is equal to Fm mg. So you can put rho Vg minus V. Sorry, this is sigma density, right? Density into volume up into G minus volume into the rho and G. So now you got this equation. Now which two things you will equate? The tan theta, right? So when you equate the tan theta, that is F E upon Vg is equal to Fm sigma Vg minus V rho G. So now you go on solving this. Finally, what you'll get? Fe will be 1.5 times Fm. Yeah, you got that?
Yeah.
So what does this mean? This means Fm is equal to Fe 1.5, right? So this 1.5 is what? As I said, Fm is equal to F naught upon epsilon r, right? So epsilon r, that is the dielectric constant, is 1.5. Did you get that?
Yeah.